Hello, I'd like to welcome you to Lynn Academy. The two simplest sequences to work with are arithmetic and geometric sequences. Okay, and as we have here, an arithmetic sequence goes from one term to the next by always adding or subtracting the same value. For instance, we have 2, 5, 8, 11, 14, and these are arithmetic. You can know this because you're adding by 3. You can see this here. If you find the difference, this is 3. 5 to 8, that is 3. 8 to 11, this is 3. 11 to 14, that is 3 as well. And that is why it's arithmetic. And now we're moving on to geometric. Geometric sequence goes from one term to the next by always multiplying or dividing by the same value. And we have this example here. We have 1, 2, 4, 8, and 16. This is geometric. And you can tell because the difference is being multiplied by 2. 2 times 2, that equals 4. 4 times 2 equals 8. 8 times 2 equals 16. The number added or subtracted at each stage of an arithmetic sequence is called the common difference. It's also identified by D, because if you subtract or find the difference of successive terms, you'll always get the common value. The number multiplied, however, or divided at each stage of a geometric sequence is called the common ratio and represented by R. Because if you divide or find the ratio of successive terms, you'll always get the same common value. Now we want to find the common difference of the next term and the next term of the following sequence: 3, 11, 19, 27, and 35. And to find the common difference, I have to subtract the pair of terms. It doesn't really matter which pair I pick as long as they're right next to each other. And then we have 11 minus 3, and that equals 8. 19 minus 11, that also equals 8. We have 27 minus 19 equals 8. So what we can identify as a common difference is 8. Since we're looking for the next term of the following sequence, of this sequence right here, the last term is 35, and we would find the next term from 35. Okay, to do that, we have our 35 plus the difference, as we already know that the if we add 8, we can get the next term in the sequence. So 35 plus 8, that would equal 43. And that's it. So there we found common difference and the next term in the sequence. Okay, now we're gonna practice with the common ratio and look for the next term of the following sequence. To find the common ratio, I have to divide a pair of terms. It doesn't matter which pair I pick as long as they're right next to each other. We have 2 over 3 divided by 2 over 9, and then we just multiply by the reciprocal, and we get 9 over 3, and that equals 3. And I'm choosing 2 and 2 over 3, and we multiply by the reciprocal, and we get 3 over 1, which simplifies to 3 as well. So that means that our ratio, our common ratio, would equal 3. And to find the next term, we have 18 times r, because this is geometric, remember. We have to multiply. And then I just plugged in the 3. 18 times 3, 54. So we found our ratio, common ratio, and the next term of the sequence. Now we're moving on to the explicit rule. So for arithmetic, we have a certain formula, a sub n equals a sub I plus n minus 1 times d. And this represents your nth term. A sub I equals your first term, and n is actually the number of terms, that's why it's tied into your a sub n. And we have d, the common difference that you're already familiar with. And this is with arithmetic, remember. So, for example, we have the sequence 3, 7, 11, 15, and 19. This is your equation. Okay, so our a sub 1 is the first term, which is 3. Our n, that's the number of terms. We have 1, 2, 3, 4, 5 terms. And we need to find our d, which is the common difference. And based on this, the common difference is 4. And we can identify that because the difference is 4. 7 to 11, that's 4. 11 to 15, that's 4, and so on and so on. Now, let's move on to geometric. And for this, to find geometric, the explicit rule is a sub n equals a sub 1 times, because it's geometric, the common ratio to the power of n minus 1. The sequence 2, 6, 18, 54, and 162. The first term of the sequence is 2. That we can identify that there. And n is 1, 2, 3, 4, 5. 5. And your r, which is the ratio, and we can find that 2 times what equals 6, that is 3. 6 times 3 equals 18. 18 times 3 equals 54, and so on. So we know that the ratio is 3. Okay, let's practice what we have learned by looking for the nth term, and that is that a sub n. Find the nth term in the following sequence. We have 1/2, 1, 2, 4, and 8. The difference does not match. You see, if we have 2 minus 1, we get 1, and 4 minus 2 equals 2, so that does not work, and we know that it's not arithmetic. But if we have 2 divided by 1, that equals 2. 4 divided by 2, that equals 2. So now that we know that, that is our common ratio, and that is r equals 2. And right here, we know the initial value is 1/2. That's simple. And from our equation, we have a sub n equals a sub 1 times the ratio to the power of n minus 1. And we're just basically plugging this in with what we have. As you see, I just plugged in the 1/2 to the initial value and then the 2 to the common ratio. Let's find the 10th term. We have our, just moving this over here. So the 10th term, that's a sub 10, because that is our n, the 10th term. We just basically plug that in, and we plug that in for the n right here as well. And now we just need to simplify. So a sub 10 equals 1/2 times 2 to the power of 9. And we know that because we have 10 minus 1 right here as our exponent, and we can just subtract. And if we simplify that even more, we have a sub 10 equals 1/2 times this 2 to the power of 9 equals 512, and that equals 512 times 1/2 equals 256. And that is the 10th term if we wanted to find the 10th term. Now let's find the first 3 terms of the arithmetic sequence having a sub 6 equal 5 and d equal 3/2. We have the arithmetic explicit rule. A sub n equals a sub I plus n minus 1 times d. And from here, a sub n equals a sub 6 as from right here. And then our a sub 1, that we don't know that yet because we are looking for the first 3 terms, remember? And your n, that is 6 because that was in your a sub n, which is your a sub 6. And d equals 3/2, that is your common difference that was given to you. In this case, that formula gives me a sub 6 equals a plus 6 minus 1 times 3/2, that which equals 5, because that is from the given in the problem. So we know that all of this will equal 5, but we really want to solve for a sub 1. We have to distribute this 3/2, and 3/2, that equals 9, and 3/2 times -1, that's -3/2, and that still equals 5, and then we're just solving for a sub I, so we just subtract the 9, so 5 minus 9, that equals -4, and we're left with a sub 1 equals 3/2, which equals -4, and then we add 3/2 and 3/2, and that's a sub 1 equals -5/2. Okay? And now that we know that a sub I equals -5/2, we have we know that a sub 2 equals -5/2 plus the common difference that was given to us, 3/2, which is -1. And we just move this -1 over here because this is a sequence, so we have to go in order. And to find that, we have a sub 3 equals -1 plus 3/2, which is a common difference, which equals 1/2. Oh, and also to find the nth term, we just need to rewrite our equation. A sub n equals -5/2 plus n minus 1 times 3/2. We're done. This is what we're looking for, the nth term, and the first 3 terms. So there you are. And that's it.